this video, I'll show you how to solve the ALEKS problem called assigning oxidation numbers. There are quite a few different examples in this particular problem, which is fantastic because you're going to see a lot of different variety here. So there's also a lot of different rules for assigning oxidation numbers. I'm going to start with this one right here because this is definitely the easiest one of all of them. If you have, like this, a monatomic ion. Monatomic ion means an ion that is just one atom. If you have a monatomic ion, the oxidation number is just equal to the charge on that ion. So that's super easy. This is a 2+ ion, so that means that my oxidation number is a +2. One of the weird things about oxidation numbers is that we write the sign first and the magnitude second, which is opposite of the way that we do it when we're writing the actual charges on an ion, but that's just how it works. So another example that we have on this particular problem is this diatomic molecule. And when we have something like this, the oxidation number is always just going to be a 0. So a diatomic molecule in this case is Cl2. Other examples, diatomic means 2, so 2-atom molecule. Other examples would be O2, Br2, H2, N2, I2, Cl2, that I almost wrote that again, F2, you get the idea. 2 identical atoms in one molecule, that means you have an oxidation number of 0, so that's nice and easy. This molecule down here is following our traditional oxidation number rules. Hydrogen traditionally has an oxidation number of +1. Oxygen traditionally has an oxidation number of -2. So since the oxygen is highlighted, this is a -2 oxidation number. And this is, I say that these are the traditional numbers. Of course, there's going to be exceptions. There's going to be times when hydrogen is not +1 and oxygen is not -2. But unless you're dealing with one of those weird exception situations, just a regular molecule like this, hydrogen is going to be +1, oxygen is going to be -2. So that leaves us to this last molecule here. This one's actually kind of tricky. When we look at this molecule, we don't really have a lot of solid guidelines to help us identify the oxidation number of carbon in this molecule. So we have to apply a rule that's not really a rule. It's like a rule-ish of a rule. The normal charges, I'm just going to kind of put quotations around that. Normal charges on ions would be their oxidation number. So when you're kind of up against a wall and you don't really have any other easy rule that you can rely on, and you can't use any of these straightforward things, then you're going to go to this rule right here. And you're going to say, well, do I have a normal ion, or do I have an atom that normally ionizes in this molecule? And we do. Carbon is not an atom that normally ionizes, but fluoride is a normal standard ion. And the charge on the fluoride ion is a -1. So in a situation like that, when you can't apply any of these other rules, then you can look at these atoms and you can say, are any of those atoms things that normally form ions? And if they are, we can make the assumption that the oxidation number is going to be whatever the charge would be if we had a normal ion. So we're going to base this oxidation number calculation on the idea, I'm actually going to write it down here, CF2. We're going to base it on the idea that the fluorine atom in this molecule has an oxidation number of -1 because that would be the normal charge on fluorine if it were an ion. We've got 4 of those fluorines in this molecule, so altogether that's a -4 charge. The other rule that we're going to rely on to help us solve this problem, I don't know where to write this other rule, the overall charge on your molecule or your ion or whatever it is always going to equal the sum of all of the oxidation numbers in that molecule. This has an overall charge of 0, which means that when we add all the oxidation numbers up in this molecule, they all have to add up to 0. So we have to add 4 with some number and get it all to add up to 0, and that's obviously easy math for you to do. So that means that this carbon is going to be a +4. This is definitely the weirdest scenario that you're going to encounter when you're assigning oxidation numbers, but you can just kind of keep in mind if any of the atoms are atoms that would normally ionize, you can use that normal ion with its normal charge to make an assumption about the oxidation number, and then follow that up with this guideline that the oxidation numbers will always add up to the overall charge.